Welcome to this tutorial to create a binary conversion quiz using Excel. We'll be creating our assignment using the Office 365 Excel web version, so go ahead and browse to your Office 365 homepage before we start, find Excel, and then create a brand new workbook. Important to say before we start, you do not need to know anything about binary numbers to do this activity, although you might have already met this in your own research. But we will be properly exploring this in Year 8. Following this tutorial, you will probably build up a little bit of understanding of binary numbers, and we're not going to get cross if you independently drop over to BBC GCSE Bite Size, for example, and take a sneaky look. That's just good learning, so well done in advance. But anything you do pick up will be useful next year. This is designed to show you simply some techniques for creating a useful spreadsheet. That's it. There will be some techniques you'll use later on in the year for another quiz style assignment, but this is not an assessment in itself. We will ask you to record your own evidence of the stages into OneNote as we go along, so don't rush. You will be asked questions about the methods afterwards in a quiz, so it's important you do know what we did and how we did it, and how you can recognise those steps. So follow the steps as a class, but you should also have access to this video via OneNote if you need to rewatch a stage later or to catch up. It's best to watch the steps, then complete them afterwards, rather than trying to do them whilst watching the video. We'll move on as a class once most people are happy to continue. So the first thing to do is to name your workbook so you can find it again later. Do this by clicking on the name in the top left. I'm naming mine Binary Quiz. Your work will be auto-saved as you go. So you should give the workbook itself a little title, so do that in cell A1. Now the first thing we're going to do is to build the structure of a binary number on our workbook. If you think about decimal numbers, they have a ones column on the right, then a tens column, then a hundreds column, and so on. Binary numbers also have a ones column, but the headings grow by multiplying by 2 each time rather than by 10. So starting over on the right, we have a ones column, then twos, then fours, then 8, 16, 32, 64, and for an 8-digit binary number, we finish with 128. Decimal digits can be 0 through to 9, but binary digits are only zeros and ones underneath these headings. More about that later. We also need a decimal column to work out what the decimal equivalent of the binary digits are. These binary number columns are a little bit wide at the moment, so we need to make the columns a little bit smaller. So we can click and drag across the letter headings of those columns and then use the little line between them to make the width a better width. 36 is ideal. We can also select the columns and force the contents to sit nicely in the centre using the alignment selection. So we'll pause at that stage to allow everyone to catch up. Feel free, if you're waiting, to explore how you would make the table look a bit nicer, for example playing around with the borders, text colour, background colour options. Everyone else will get a chance to do that in a little while. Right, now to get the mechanics of the binary number working, and to do this we need a sample binary number. Now it doesn't matter what number you type in, but because I've got no imagination, I'm just going to put in alternate ones and zeros. Now we need to enter a formula in the cell J4 to turn the ones and zeros into the equivalent decimal number. So a little look at decimal here. So we can apply the same idea to binary. Now if we had, say, the number 368 in decimal, the 3 in the 100s column means 3 lots of 100, and the 6 in the tens column means 6 lots of 10. So the same is true with binary. The 1 below the 128 means we have 1 lot of 128 in this number. But we have no 64s, but we do have a 32, we don't have a 16, and so on. So as we've done before, to get Excel to do the heavy lifting with working out the answer, we just need to tell it what calculation we want it to do with the values we've already got in the cells. So we're going to enter a formula, starting of course with an equals. Remember, formulas always start with an equals. We want to multiply the 1 in B4 with the 128 in B3 using the star-shaped symbol, the asterisk, on the 8 key on the keyboard. It's also on the number pad on the right on a full-size keyboard. Now I then add on the value of C4 and the value and C3, and then add on D4 times D3, and so on and so on. I'm remembering that I want to do this with whatever number is in those cells, so I'm actually clicking my mouse on each value, so the formula includes the cell reference. Now there might be a point where the growing formula stops you being able to click on the cells, but you can just click nearby, any cell will do, and then use the arrow keys to move the selection to the one you want. Quite an impressive looking formula, don't you think? Once done, we can press return and see the result. 234. This actually seems a little bit large, to be honest. It's got 128 and then 32. There's no way you could get all the way up to 234. I've clearly made some kind of error. And if I delete the number, you can actually see that I don't get all the way down to 0. I actually get 64. You might have spotted the error as I typed. If I press F2 at the top of the keyboard, it actually highlights the full colour formula showing all the cells being used. The 64 is the clue. If I look in that particular column, you can see that I've actually added the 64 and the binary number together instead of multiplying them. So a quick fix, replace the add with a multiply, and let's test with some of the smaller values to see if we're happy that they're right. So if I put a 1 under the 4 and also a 1 under the 1s column, I should get 5, which appears to work. If I add a 1 in the 8s column, that should raise it up to 13, 8, 4 and 1. If I add a 1 in the 2s column to give me all 4 ones, that gives me a total of 15. And if I drop the 1 at the end, it drops it down to 14. All seems to be working correctly. So time for a pause to ensure you have your formula in place and test it with a few 1s and 0s. Take a screenshot of the formula itself and provide 2 examples of different binary numbers and the equivalent decimal for your OneNote notebook. Now I'm going to put the original number into the row below and extend the formula so we can do some more numbers. Now we have the formula sitting in J4, but I want to copy this to the cells below, so we can use the clone handle in the bottom right on the cell to drag this down to the cells below. Unfortunately, the result is 0. So what's going wrong? Notice if I add digits to the number above, the value actually starts to increase. Very odd behaviour. If I click on the formula bar, we can actually see the problem. We programmed our formula to multiply the numbers with the value immediately above them. But when we drag the formula down, it obediently did the same thing. It didn't know we wanted to keep the 128, 64, 32 and so on. Now one solution would be to correct the values by simply adjusting the top number so that each of the cell references points to the right value. You can actually do this with the mouse, as you can see I'm doing here. Not too tedious, but not something I'd want to do for every single row on the entire spreadsheet. What I want to do is to be able to tell Excel not to change the cell references for any of the numbers in the headings, the ones on row 3. So we can do this using the dollar symbol, which is Shift and 4 on the keyboard. If we sneakily put a dollar in front of all the 3s in the cell references, this will fix that number when the formula is cloned and keep the formula working all the way down the spreadsheet. Sure enough, if I clone the formula down the next few rows, the formula does appear to keep referencing the right values. So I can now drag this formula down a few more rows, confident it's going to give me the right value. So time for a pause again. Copy your formula down and make more rows yourself and try some binary numbers to check it works. Include a screenshot of your new formula in your OneNote and add some different binary numbers to check all the rows appear to work. Take a screenshot of all the rows. Now to turn this from a converter to a quiz, we want to generate a set of target numbers for the person answering the quiz to turn into binary. So write in 10 numbers starting from smaller numbers and moving higher, making sure you keep to 255 or below. Now over on the right, I want to detect whether the numbers we've calculated from the ones and zeros matches that target. So we can use an if function to do this. The first thing we enter with an if function is called a logical test. This is what we want to detect as a success, and in this case, it's whether the cell J4 is the same or equal to the cell A4. A logical test such as this will either be true or false. The if function then lets us specify what we want to be shown if the result of that test is true and what we want to be shown if the result of that test is false. So I'm using correct and incorrect. As you'll expect, we must make sure the bracket we opened at the start of the if function has a matching close bracket at the end. We can use the handle, bottom right, to clone this formula all the way down the sheet for our 10 rows. If I enter the correct ones and zeros for the line with 9 on it, you'll see that the formula identifies the correct answer. So let's try the 21 as well, as it's a smaller answer. Yep, that one seems to work as well. So another pause, try putting in a few target values of your own and the formula to identify if the answer is right or not. And again, screenshot the formula and a few examples showing correct and incorrect answers. Right, time to tidy up this sheet so it works a little bit better. We want to get the correct-incorrect formula to only make a decision if the user has actually made a guess. So if the value of their ones and zeros is 0, we want to display nothing. This gives us a clue on how we can write an if function to allow us to do this. So what we're going to do is create a new if function surrounding the existing one. That's called nesting an if statement, putting one inside the other. So I'm actually going to cut the current if statement out using Control X. So I'm selecting all of the existing formula, not the equals at the front though, and pressing Control and X at the same time. It vanishes. Don't worry, it's stored in memory and I'll add it again later so we're not confused. So one way we could detect whether the user's typed in a guess is to see whether the value to the left of the formula is bigger than 0, since 0 means they haven't entered any ones and zeros. So we can check if cell I4 equals 0, and if it is, print absolutely nothing. Now we can't just leave the value if true blank, we have to put something in there, so we can use an empty string denoted by 2 double quotes with nothing inside. Now for the value if false. Now if J4 is not 0, we actually want the if statement we had before, deciding correct or incorrect. So this is where I'm going to paste the previous if I just copied back in using Control V. Like before, a quick check of our brackets. Now we opened 2 brackets, one at the very beginning and one obviously in the inside if statement. So we want to add an extra one on the end to make sure we also close 2 brackets. There we go, one if statement with another if statement nested neatly inside. So let's press enter and see if this works. So I'm going to clone the formula down and then I'm going to try the line with 135. So 135 needs the 128 switched on, and that actually just leaves 7 left over. So no other ones are needed apart from the 4, the 2 and the 1. Good, that works. So I can test a few more values to see if they seem to work and then change the heading from binary converter to the more advanced sounding binary quiz and introduce a bit of neat formatting to make the sheet look a little bit nicer. So why not do the same yourself? Record a copy of your adjusted correct, incorrect formula and a screenshot of your final quiz. Right, now one little bit of final formatting we might want to do on the sheet would be to colour in the correct answers green as they appear. Formatting the changes depending on the contents of a cell is called conditional formatting, and it's a really nice feature of Excel that's useful for a lot of tasks, as you'll see in the future. We can add conditional formatting to the final column by highlighting these cells, and then we can find conditional formatting on the toolbar. Now, because my browser is zoomed in quite close, mine's in the ... extension menu on the right. That's where we'll find conditional formatting. There's loads to explore here, but we just want to highlight cells that contain the word correct. So we want the top option, highlight cell rules, and in there we want to find the equal to option. And then we just simply fill in the form. Highlight cells with a cell value equal to. Now we just need to enter correct here. Now be careful just to type a number or text. Don't use quotes around the text as it'll add those later automatically. We can choose from the selected options. Green text and background seems okay. And when we click done, we can view or even edit our rule using the little pen icon in the bottom right. So once you're happy you've got your rule ready, then screenshot it for the OneNote and resume once you've done this. Now our quiz works one way. It gives a decimal number and the user types in the ones and zeros, and the quiz detects whether they're right. What if we wanted to provide the ones and zeros and the user types in the decimal guess? To do this, we'll want to copy paste to make a brand new copy of the current quiz. Notice when we do this, the widths of the columns don't get copied. So we need to match up the column widths. Now you can do this by just clicking as if we were planning to change the width of one of the existing columns, just to see what the width actually is. 36 pixels. Yeah, I remember that now. So we can change the new ones to match. Right, now I'm putting in some ones and zeros to provide some questions to guess. It's important really to start with smaller values at the top and work your way bigger as the numbers go down. The column on the right will automatically, of course, be guessing the value. And I can delete the target numbers on the left to make a space for the guesses where the user is going to enter the guesses. So we also therefore need to hide the auto-generated answers. To do that, right-click on the column heading that you want to hide and select Hide Columns. So there we have it. Time to fill in a few more instructions on the sheet, always useful. A quiz that tests the student's binary knowledge, and you can keep this and use this in Year 8. You'll find it useful. Meanwhile, try and complete the quiz yourself and take a final screenshot of your completed sheet. Well done for completing this tutorial, and feel free to watch back again before we ask you any questions about what you did.